cornerstones and caches. We're going to be talking about some current work based on improving performance in areas of RGW. So, as you know, S3 puts a lot of interesting demands on metadata and different kinds of queries that can run. Lots of workloads generate different read patterns on both the local disks and also on the entire surrounding unit of network storage, especially if you're running analytics thing. And I think Matt's a little more familiar with that kind of area. Anything you'd like to add to that?
Okay, we'll try. The thing I want to, the one part I want to contribute, I guess, is that we're about to hear a conversation about, I guess, a step on our journey to explore alternative ways to organize bucket indexes in Ceph object storage, and that's a big topic that deals with large how to enumerate S3 buckets from out of RADOS. But in this case, we're going to talk about it in a microcosm of that. We're going to talk about how we maintain those views using in our D4N cache, which are essentially our D4N is a write back cache. We're going to talk about how to build merge bucket indexes, and how this technology is we're prototyping in the cache. It's possible that it may be addressable, maybe in the future address the large topic of indexes at scale.
All right, thank you. So these are the kinds of problems that in general RGW has to deal with. In particular, though, I'm going to be talking about caching and what our current caching efforts are. So right now, we've got a thing called the Directory-Based Data Center Delivery Network, or D4N. And what is D4N? Well, to know what D4N is, you have to know what D3N is, the Data Center Data Delivery Network. If you go a little too far, you get D2N. Well, D2N is actually just D&D, so you might as well just be doing a role-playing game, which is not what today's talk is about, thankfully. The Data Center Delivery Network basically is designed to do local caching, right? So D3N was built around NVMe caches and the idea that an oversubscribed network needed to reduce bandwidth trips across that network. And importantly, it's only caching immutable data, right, from RADOS's perspective. So you get what are so-called tail objects. D4N is developed to do the same thing, only now across the network. So offloading to a different database, essentially, something with different properties. The goal is to add write-back caching, right, which currently wasn't possible, and enable data sharing. So other parts of Ceph, even anything like that, as well as elastic scaling. So the more RGW instances you get, this solution, whatever we end up with, needs to scale in proportion to that.
Well, the write-back caching.
Yeah.
Yeah, D3N scales too, but
yes. But this is a
write-back cache.
Right. So the current status in RGW, this is under active development now. We've got a single node D4N prototype that's working using Redis as a backend. That's under really active development. I think I list some of the people who are involved in that right now. There's work on getting distributed block caches and some kind of test suite together. And then the component that I'm working on is actually supporting transactions, multi-commits, and different things like that. For that, one idea that we've had, which is Matthew's idea.
Which is it?
Well, to deploy a different kind of database.
Oh, okay.
In particular, FoundationDB is what we're looking at. It's a database from Apple. It's a KV store. It supports ACID transactions from the ground up. In fact, everything runs in a transaction in FoundationDB. It's got a shared nothing architecture, and timestamp ordering and transaction ordering are the same. So it's got a lot of the properties that we really want for bucket ordering out of the box, and we think that could be a really strong match. Basically, it's got, out of the box again, in-memory transactions, built-in distributed storage, so it's going to handle all that stuff for you. It's its own database world, and even configuration and stuff like that. It has ways of handling that across the federation of FoundationDB nodes. it's got extensive testing. There's actually a lot of really interesting automatic deterministic testing used by the people who designed Foundation DB. And the paper at the bottom, if you really want to know details, that's a very detailed explanation of how the whole thing is architected, and it's quite an interesting read. Our goal is to build a D4N driver using Foundation DB as a back-end sync, right? So where we're using Redis in one prototype, we'll also be able to try it with Foundation DB, and we're hoping just to get the properties that it provides natively enabled in D4N. To that end, we've got a client library now written called libfdb, and it's just wrapping their C API in kind of a more C++ friendly thing. libfdb speaks STL containers, function objects, so on and so forth, instead of just buffers, so you don't have to write code at quite that level. And we actually have support for buffer list, so you can just give it a Ceph type, and that is user extensible. Using it looks kind of like this. Here's just a quick example. Here's a map of construct pointers. You make a database, set a key there, that's missing a database handle in there, but imagine that's there, and then get your keys out, right? Both of those operations actually happen in an implicit transaction. And if you wanted an explicit one, you would tell it to make a transaction, you'd get a transaction handle, and when those go out of scope, that all gets cleaned up for you. So the transaction is either committed or not committed, depending on the type of operation. So the set, for example, will commit, whereas I think the get right now is going to just let it get eaten by the FDB garbage collection. It's got a cute logo. Got to have a cute logo, very important, most important part of any project. So right now we're using libfdb to build this D4N sync, and we're trying to re-architect the backplane for D4N so that we can fit in more kinds of databases. So if we want to use Redis, we should be able to use Redis. If we want to support, I don't know what would be a good one besides Foundation DB these days, but there's probably some other options we could look at.
Many possible things.
Yes, we can then get those to plug in there. That's pretty much the gist of the project. Any questions about it? I know it went by kind of fast, but it's the end of the day.
Important point.
Any questions? Going once. Yes? Can we put all the bucket index information in there? Yes, that's exactly what we're doing.
Hey, verily, you can do so.
Yes, precisely what we're doing. Yes, well, I think it'll make a lot of people happy. And the main thing is Foundation DB's key space is a total ordering, so you actually get that for free out of it, which is pretty cool. Well, more for free,
Yeah, I think original plans, and indeed, I think it's before Casey started or Jesse started on this. There actually were upstream contributors who experimented with using Foundation DB in a different, using a raw interface or C interface inside of RGW RADOS. That wasn't there, and they reported. They abandoned this work, but they did report some initial results to the mailing lists that said that they claimed to reach parity with at least with the native indexes and they hadn't done that much. We don't know exactly what that meant in terms of how many nodes they used and what size buckets and other things. But just over the last several years, we've noted that Foundation DB is emerging as becoming prominent in circles we travel in, and has more and more of the properties that I think we were looking for this. We want to prove whether that's the case. We would like to. So yes, one of my goals is to see whether we can put entire the 10 billion or plus object range, object loadings into indexes for a RADOS cluster, and we might experiment if this worked, we might experiment with putting them converging them with a RADOS cluster. And, this is an alternate idea to figuring out how to make OMAP do what this does. What a classical database does efficiently, but in fact to do that.
Yeah, just to add to that again, one point I may have glossed over a little quickly because I can't really read the slides, is that everything in FoundationDB also happens inside transactions natively. So the whole thing is actually built for that from the ground up, and that's a semantic that we are really struggling with implementing right now. It's
If you were attending Radoslav Zinski's talk, you know something about what it is like to work with OMAP. OMAP has some of the required atomicity, but only in a very restricted manner that is essentially orthogonal to the placement rules of RADOS, and gives us a set of uncoordinated ordered sequences at many OSDs arbitrarily distant. That's served us adequately up to this point, but it is not. It is giving us trouble as a primitive beyond where we are, and it's time to look at other alternatives.
So if you're interested in this, there is a PR up. I didn't give the number, but you can just search for FoundationDB or libIFDB. Here are some resources if you're interested in what we're generally doing with caching or for FoundationDB in general. If there are no more questions, yes?
You covered how the Redis cache will be used as a write-back cache. Do you have any strategies or work done on caching reads?
Oh, okay. D3N already caches reads. Okay. So I mean, and our version of DB here also we didn't. I think there's some good talks on D4N and D3N. You can learn more about them. Our D3N is. I think we discussed this, or I saw it with someone elsewhere. I mean, the research version of D3N is an n-way set associative rack scaled thing, but it's caching immutable data. It's just caching the piece, and it was written with Ceph in mind. So it's caching pieces of RGW objects that are immutable. So if you write, so it's a recache. It's a pure recache. D4N will.
But only for the immutable pieces.
Exactly so. You can't cache. It can't cache a head object at all. So maybe we could change that. I mean, it could cache a multi-part objects don't really cache any data in the head object. So maybe we could do that. But anyways, D4N still does that. D4N is still a recache. Pardon? But it can cache anything. It can cache. It caches the entire namespace. But because it's a write-back cache and because it's a good idea, it also caches. It also deals with bucket listing. You couldn't do S3. We couldn't have data resident in the write-back cache if we couldn't list the bucket and see all the data.
I guess maybe I'll narrow my question a bit. Is there any planned work on caching mutable data for reads to speed up reads?
Well, absolutely. The goal is to convert. Is to cache is to do read after write and et cetera. So the goal, a write back cache in this, at least as I'm in this case at least, the D4N write back cache is also a read cache.
Got it.
It is. No, things that are interesting future work, and D4N would really involve multi-tenancy, policy management of the cache, so selective caching for unique workloads, and this kind of stuff. So, but this is the early days, but the research cache doesn't have all of that, but it has. But we want to have that. We need that for practical purposes in Ceph. It does have other cool things. It's got an intelligent prefetcher. For example, this thing, the research prefetcher snoops on Spark tags and understands what Spark's going to do and does critical path on multiple Spark workloads at once and keeps those things in cache. And so there's a lot of cool stuff. And we're using D4N. We're getting there to using D4N in the data path for our S3 vectors implementation, so it can cache what is needed to be cached for the vector implementation, prioritizing the top of the tree and other stuff. So it's cool stuff. It's keen.
No problem. Thank you.
Right.
Anything else? Yes. Mm-hmm.
That is also true.
Yep.
Well, it probably does.
There's nothing in anything that we've built so far that prevents something like that. I'll put it that way.
Yeah, I mean, I guess it depends on, I guess it depends on the same properties, some of the same considerations that a stretch cluster depends on. Can the transaction, can the latency of the different stages of the transaction execution deliver satisfying performance? I mean, I know. I mean, pretend instead of a stretch cluster, it's just an overlay. It's just Skynet or whatever. It's just the data, but it's just the data jack. The way foundation DB is abstract, but it's a B plus tree oriented system, and it's transactional, so it has traversals. And it has hotspot caching and other clever stuff, but its routing architecture will have to work adequately on the latency. You know what I mean?
Yes.
For latency within the architecture we provide for the nodes.
Yeah, and just to add to that again, it kind of depends on what the underlying semantics of both of Foundation DB and what you've built with Foundation DB are. And it's really meant to be a cornerstone for building other kinds of data stores. So it's actually very, very flexible. Which means that building something like that may not be something it does out of the box, but you could engineer something, a simple matter of engineering. Right?
I mean, it's used at very large scales. I mean, my impression is that it would work really well if we have enough network capacity and the right latency.
Right.
Not true. Jesse was used the phrase vector clock earlier today. I don't know whether it uses vector clocks, or if it does, what depends on it.
Implementation issue inside the database, I would imagine. I do know that they have a whole lot of automated testing at really impressive scales. I think there's a whole company that I'm drawing a blank on right now that has basically
Snowflake does. Apple has a bunch.
Snowflake, Apple
owns it, or at least it has the team that makes it.
And there's another company that just does testing, I think.
Oh, neat. Okay.
Testing tools for it.
Wow. That's actually very interesting.
Yeah, and I'm drawing a blank on the name. I'll get it to you later. But that's another attractive aspect of Foundation DB in particular. We're trying not to make too many assumptions in the library itself, right? It is wrapping libfdb, wraps Foundation DB obviously, but it itself doesn't make a whole lot of assumptions, and you can if you need specific behavior, you can kind of reach in there and say, give me a raw database handle and do the magic stuff. We're trying to get the Ceph code to be fairly agnostic about what it's running on top of. Any other questions? Okay, well, thank you very much. I'm sorry for the hiccups, and I appreciate your time and patience. Thank you. Thank you very much.